So now we come to details of the course, going through each of the lectures. The lectures are divided into sections, units, and lessons. So, say this course is an overview course for the data science curriculum. As we discussed, it covers a mix of applications and technologies. And we have this rallying cry: use clouds, run data analytics collaboratively, process big data to solve problems in X informatics. The technologies give us an overview of parallel computing, clouds, and some data analytics. Not all data analytics is a huge field. And we have many applications, many values of X. We have some discussion of software, though writing software is not a major focus of this class. There is some opportunity to do that. And we have two tracks or approaches. One uses Python, which can either run on your local machine or, in fact, on FutureGrid, the backend cloud. But Python's pretty easy to run on your local machine if you have a laptop. If you just have your favorite tablet, maybe you want to use the cloud version. And Java, which can be run on the cloud, or which would either be FutureGrid using the so-called OpenStack technology, Amazon Azure. Again, you can run it on your laptop in a standard fashion, which is probably a little bit tricky to set up. So that's the approach. So as I said, this set up as a MOOC with 35 units, actually over 35 units. The units cover the sort of intellectual content of the course, plus various tutorials on technologies. And a unit is sort of the equivalent of a normal lecture, 30 to 90 minutes. And we have those three courses, and they will choose a subset of the available units. There is a motivation unit which describes why the topic of the course is important, and it's covers the whole material of the course. It was designed to be looked at by anybody, whether or not they were associated with the course. As I said, units, actually the course is arranged in sections. A section is an intellectually coherent discussion. It might be anywhere from 1 hour to 5 hours in length. A section is divided into units, which is, I say, 30 to 90 minutes. And units are divided into lessons, which are 5 to 15 minutes in length. And this 5 to 15 minutes in length videos make up the course. The homework and mentoring are separate from the MOOC lessons. There is a built-in mentoring through Google Community Groups. So we have a software, and we'll indicate which of the units has software. And as mentioned, the software is offered in tracks, Python and Java, and it's often allowed to be run on clients or clouds. We have what I call side MOOCs, which actually just look like ordinary units to you. I call them side MOOCs, and the mechanics of the software is something that can be used in many courses, and so those particular side MOOCs might be reused elsewhere. For every unit, you will find a list of useful resources. And those are largely websites, because that's the important way to label a resource these days. So this one site here covers the entire course. We have this, here we are here, introduction. That's the presentation we're suffering through now. The next unit is this motivation unit, which is really, as I said, standalone, with the goal of it to motivate why the course might be interesting, but not central to the intellectual discussion of the course, and that it covers the whole course and sort of an executive summary. Then we get to the course itself, which, like any good thing, starts with an introduction. What is big data, data analytics, and X informatics? It is followed by some technology, these side MOOCs, one on Python. We go through these particular technologies, NumPy, SciPy, and Matplotlib. And then we have a side MOOC on using FutureGrid for Java and Python. Then we come to the first value of X, which is physics, and in particular, the discovery of the Higgs particle at the Large Hadron Collider. LHC is Large Hadron Collider, and this has technology sprinkled through it, basically based on these side MOOCs. It explores sort of basic statistics, events, histograms, modeling, central limit theorem, things like that. Now we come after that, we have lots of values of X, in fact, 51 values of X. We have a survey of lots of different big data use cases, and that's divided into 3 units. Then we have another side MOOC on a specialized piece of software you can download called PlotViz, which displays point distributions in 3 dimensions. Then we have 3 units on for the value of e-commerce and lifestyle, which is technologies underlying Amazon, Netflix, and things like that. And then after that, we get some technology, which is the Python or Java, the actual recommender systems, k-nearest neighbor algorithm, which are sort of at least one of the simpler approaches to this type of application. And we also have some discussion of clustering and some general remarks on heuristic methods. Then after that, we reach a sort of pause, so we decide to go and look at the core technology, the infrastructure. So we have a single unit on parallel computing, because everything is done in parallel. There's this concept of horizontal scaling, that the way to solve big data, which is a big problem, is you have a big number of computers. Those computers are partly individual cores, because all the chips are made up of cores, and then maybe you get 12 to 16 on the latest server you buy today. But then you also can put different chips together or different servers together, and then you get huge numbers of cores, hundreds of thousands of cores maybe, servicing a particular value of X, particular application area. So we do parallel computing from a fundamental point of view, then we do supercomputers, for instance, and cloud computing are actually as far the same as far as they invoke parallel computing. So then we do, after parallel computing, we do cloud computing, and we cover the infrastructure and the software and things like that. And after that, we do 2 units on web search and text mining and their technologies. And we follow that with technology, a unit, big data applications and analytics with k-means, a well-known clustering algorithm. Then we cover an important cloud technology, MapReduce. And after that, we show how MapReduce could be applied to k-means. These are done in Python and Java. And then finally, we give another example, PageRank, which is an interesting algorithm in web search. And then the course ends with 3 shortage units on different application areas. Health informatics is very important. Sensor informatics, the world is going to have 75 billion sensors on the internet in 2020. And then we're going to do remote sensing and the use of radar instruments to discover what's happening in the North and South Pole. On this slide, things marked colored red involve software. Not necessarily you programming them, maybe you just running it.